So it's 2018, it's a TikTok, and it's mandatory to include AI, isn't it? That's the trend. So to continue this trend, here I stand. My name is Aakash, and I'm a Python developer by profession. A deep learning fellow man. And today I'm going to use a lot of big words to sound like I'm a really genius guy, which I'm not. So let's begin. So let's begin with the spectrum of AI. We have been hearing this buzzword a lot, AI, machine learning, deep learning. So where do they stand in terms of the spectrum? Let's analyze that. So AI is all about the cognitive abilities of computer. It's like when the computer starts thinking, we call it AI, but actually there are a lot of things that actually is happening on the back end. Machine learning is a branch of AI that where it deals with the concept of learning from data. So this is all about ML. And what about DL? So deep learning is that particular field of machine learning which primarily associates itself with what we call the artificial neural networks. Okay, so fancy things. So one of the reasons why deep learning is booming these days is mostly because of its performance on huge amount of data. So talking about the scalability, whenever the other older or classical machine learning algorithm fails to perform at a higher data container, deep learning shines there. So this is the reason why big companies like Google, Amazon, and whatnot, they have been using this state-of-the-art technologies. So today we are going to do a bit of dissection with a simple neural network architecture, and we will be doing a bit of finite classification operation. We will also talk about some of the state-of-the-art research, what's happening out there in 2018, and we'll talk about that biggest question: how do I get started to AI? This is like the most popular question of 2018. I'm probably sure about that. So, talking about neural nets, I'm really sorry, but they are not the model of human brain. The way media is depicting it as simply an artificial human brain, it's not, because human brain is an incredibly complicated architecture, and we all know that. What it can be said is that neural network architecture are actually a directed acyclic graph, which can be trained through some method called backpropagation. Now, another fancy word. Anyone? Backpropagation? Ever tried it? Ever used it? Ever heard about it? Ever implemented it? Ever implemented it from scratch? Okay. We'll begin with the structure. And this is probably the most comprehensive and detail-oriented structure of neural network I've ever seen in my life. And that's this. So, some black magic is happening, X is being fed, and Y is coming out, popping out, and lots of stuff like that. But let's try to open this Pandora box a little bit, and you'll see some nodes and stuff, some crazy complicated stuff. You can see some layers, you can see edges that show some weight, nodes that show some computed values, and activation functions, blah blah blah. So we will deal with these things. We will deal with these complicated looking things, and we're going to dissect everything from scratch. So I think this is a bit of fun example. So I need a yes or a no, simple yes or a no. Is this Adafi? Yes. This bad boy? No. So notice that we as a human are probably one of the most accurate binary classifiers. Our brain can understand what's in the picture. Our brain can understand what's in the visual parameters. So these are the things that we can understand very easily, pretty easily. But what about computers? It looks like an easy problem, but it's not. So what actually a computer sees is something like this. So this is an image, and the computer is treating it in an RGB format. Let's say we are converting this image into an RGB format. So literally, the computer is seeing it in the terms of bits and these numeric values of red, green, and blue panels. So what we are going to do now, we are going to collect a lot of data, and this is not about just collecting the data. There are so many parameters that needs to be looked up while designing a proper neural network. And in this example, we are going to collect some data where we have the pictures of Dafe, because we need to make the computer understand that this is the bird, and other examples which are not this particular bird or any other random images with class level, of course, because we are doing a supervised learning in this case. So we are associating each images with a label. So this image is Dafe, yes, 1. This image is not a Dafe, 0. So it's a binary classification, 0, 1, 0, 1, and sort of like that. Okay, so the idea, you got that, and you're converting these RGB images, this one that you're seeing here, into a vector. So this is a plain vanilla neural network architecture. I'm not even talking about convolution. I'll be talking that in some other slide. So we are actually feeding these dimensions, these vectors of certain dimensions to a neural network model. And these black nodes are storing these values, these corresponding values of the pixels. So what we just did here is we just unrolled the values of this RGB, and we just simply fed this to the network. Now you can see some of the things like edges and node values. What are these things? So it's actually this part is actually storing weights, something called weights. So weights are numeric values. You can simply understand like that. Node, on the other hand, is also some numeric value that is computed from certain calculations, and the calculation looks something like this. We have something in the layer 0, which is the value of x. This is layer 0. We initialize the weights. We initialize the weights from certain methods. There are some method of initializing the weights, and which I'm not going to talk about. What we do is we feed forward the network. So in this case, we are feeding this Dafe image, or let's say the pixel values, and we are feeding these parameters forward. So some values are associated with these nodes, and some are computed after doing this operation. The parameters are moving towards this part, and then some are moving towards this part. So we're just going towards this direction. So what happens at the end is that we'll be getting this value of y hat. Okay. So in the very beginning, what happens is we may be very far from the target, because in this case, this is the image of Dafe. So the actual output should be 1. But we're not going to get any close to 1, because this is just our first iteration. We have not even trained the model yet. Now what happens is your network identifies that there's a problem. There's a mismatch, which is called a loss. So a loss is just or the cross entropy loss, we call it. It's just the difference between the actual output and the predicted output. So in the first case, let's say we predicted 0.3, but the output should be 1. Now there's a problem. We are not even classifying it properly. So what we do is we go back. We go back and we replicate the same thing. But before that, we update these weights so that these updated weights can fit into our model. So we go back using the method called backpropagation, and then we again move forward, we again go backward, we again move forward. So this happens like thousands of times. So ultimately what happens is you get a proper architecture, properly set it up weights, so that finally your image, or the new image, that's the test images, is closer to the value of 1. So this is how a simple neural network architecture works, fundamental level. So did I talk about gradient descent? No. So this is a gradient descent GIF. So what it does is it actually goes down the hill. This is actually a loss function. So the loss function is actually going down the hill so that you are getting the minimal loss. And minimal loss means your accuracy is great. So this is one of the algorithms where, once upon a time when I replicated this algorithm to one of my friends, I was moving down the hill and I was saying that this is how gradient descent works. And I almost broke my leg that day. So I have some deep-rooted hatred with this algorithm. Nevertheless, I respect this one because this is one of the most important algorithms in case of neural network. So you feed the new test image, what you get is you have these operated weights, and finally your y hat will be very close to 1, which is Dampé. And you can bring a non-Dampé image in this case, and your y hat value can shift towards 0, which is non-Dampé image. So this is how a simple neural network architecture works in a fundamental level. But this is not the state of the art, because this looks a little bit childish, like going back, forward, and just feeding this vector. It really looks a bit awkward. So what we do is we introduce something called convolution of neural network. So what about it? Tried it, implemented it. Let's do it. So a convolution neural network is actually performing mathematically. It's performing cross correlation. So any mathematicians out there who can who knows the difference between convolution and cross correlation? Anyone? Actually, it doesn't matter because we are doing the similar operation. Both of these things result the same thing. And the thing is that you have this input image with some pixel values. You have the filter that is selected in a random basis. There are some method of selection of filters as well, and you are extracting the features out of the filter. So what happens is this is the process of feature extraction using convolution operation. And upon several feature extraction processes like convolution and pooling operations, ultimately what you do is you feed this extracted feature to a fully connected network, like we saw that earlier, isn't it? So ultimately what happens is this 3 is outputted as 3 here. So this is how a convolution neural network works in a very fundamental level. This one is actually a pretty cool, interesting implementation of CNN from Ryerson University. And what you do here is a simple web application. Again, this is not mine. So you draw a number, and what this application shows is that in each of the convolution layer, what is actually happening, what are the weights and values, biases associated with these layers, and ultimately what you get is the number 7. So this will show you an exact depiction of how CNN works in a fundamental level by actually showing you the results. So you should try this out. We also have something called mask RCN, and this is the state of the art so far. This is the state of the art technology. What it does is it detects the objects, it locates the objects and masks them like this. So what it's doing is it's actually masking your entire architecture. Like you have a bicycle or you have a person with the probability values, and this is actually extracted from FAIR, Facebook AI research platform. Called Detectron. Heard about that? It was open source 3 months ago. Created a lot of buzzword at that time. And so where do we stand in this object detection thing? We have come a long way. I'll talk about RCNN, mask RCNN. We have seen things like ResNets, YOLO. Anyone YOLO? Not you only live once, but this is a separate algorithm. Anyway, this is the trend that's happening so far. What about recurrent neural networks? Now, these architectures actually analyzes the sequence models like text-to-speech processing. You say, "Okay, Google," and she says something. And the music generation, of course. So this is one of my projects. Okay, moving on. This was a music generation problem that I did with long short-term memory a few months ago, and I couldn't play this. Sorry for that. Okay, so generative adversarial network. If someone says you what is the best thing in this universe, I'm going to tell that it's GANs. And the reason is because GANs are the most sophisticated as well as the most creative architectures I've ever seen in my life. And the reason is because I'll talk about the reason first, but before that, I'll talk about the architecture. There's a network called generator network and a discriminator network. So a generator network, what it does is it actually tries to fool the discriminator, and the discriminator tries to be not fooled. So it's simply like it's on a war between two. And finally, the predicted labels are treated as the output. So GANs can actually do a lot of things. It can generate images, and it can generate videos just like this. So we have this semantic segmentation mask problem where this mask is converting into a photorealistic video. So the video that you're seeing on the right, this one, is actually not a real video, but something that is generated by this network. And can you recognize these people, these celebrities? Seen somewhere? No, actually this is created by this neural network. So these are the fake celebrities that are created by GANs. Again, this is a generative network, so it generates the fake data. And this is actually useful for a lot of things, like, data generation is useful for other kind of treatment of AI stuff. So GANs are actually useful for this sort of stuff. They can also do a lot of things like background to color processing, aerial to map, day to night, night to day. This is a very popular implementation. It's just a photo. Also, there's a list of curated collection of GANs. You can check that out if you are really nerd like me. Okay, so the roadmap. A lot of questions, a lot of people have been asking this lately. So what I would say is, we need to begin from the scratch. You need to go with the inception process. And I don't think that you need to be an expert in any language to start knowing about deep learning. The fundamentals would work, but in a certain level that you're confident. Some linear algebra, probability, and calculus stuff you need to know, because this is all about mathematics. This is not just about height. This is a very serious discipline that includes a lot of patience, a lot of commitment, and a lot of maths. And some of the masters like Andrew Young, Yoshua Bengio, I think you have heard about some of them. Probably Andrew Young, anyone? Yes, most people have heard him. Ian Goodfellow, the creator of GAN. The long hard practice would be like you need to take some hardcore courses, which is actually hands-on and will teach you some of the creative and the practical approaches towards deep learning. So my favorite is deep learning specialization, Faster AI by Jeremy Howard. Anyone tried it or heard about this specialization courses? Yeah. So, and what about books? My personal favorite is Deep Learning book, which is again written by Ian Goodfellow. And one of the most important things, I guess, is to create a scratch implementations. Like in the beginning, I asked about back propagation and implementing that thing from scratch. So I think the most important thing is to understand from the scratch point of view what is really happening in the algorithm, and then jump into the frameworks. Because frameworks are really going to solve most of your problems. But if you have to tune the things, if you have to tune your hyperparameters, if you have to make some amendments, then it's going to be a lot difficult for you, because you are not understanding this concept. Okay, the yellow light is shown, not the light, but the paper. And there is the Zen mode, where you need to do a lot of research, a lot of hard work is based on it, and you need to find the state-of-the-art models and train your data in similar way. So this is a very, very hard process, but actually getting to the Zen mode would be really interesting. And I'm not even in the Zen mode. I'm not even in the long hard practice, maybe, or probably the second part. We have papers with code. This is a repository which contains all the deep learning papers with the implementation. So one should check this out if somebody is going to learn about these things. So what lies ahead? So deep learning is transforming almost every industries today, from agriculture to medical or engineering to finance. Deep learning is transforming a lot of areas, a lot of research places where it really needs many amendments. So I think this is one of the most revolutionary, one of the most important mechanisms in today's world. And I really think that the way media is depicting deep learning or AI in general as something evil, from a perspective of someone who is into this field, into this business in a very serious way, I really would like to say that this is something not to be called evil or something not to be feared of, but to be practiced a lot, so that we can solve these kind of problems and other problems in the future. And talking about the context of Nepal, I think as a country, we may be underdeveloped, but talking about our advancements in these kind of research and development actions, we surely can do much more greater than what we are today, and we can go neck and neck with the developed countries in case of research. So yeah, I am starting with Nepal or AI. How would you like to start? Thank you.